For the problem we have here, we're asked what is the low frequency voltage gain for the amplifier shown. It looks like this. So we're going to want to look at the notes linked below the like button on page approximately 148 to find our common gate amplifier. And it looks exactly like this. It's not really a different way that we're going to be looking at it. So taking this, what we can do is say, well, we want our AV. So if we look at the notes, we're looking for our AV. There's multiple different ways to solve it, but this is going to be the simplest way for us currently. We can take this and we can plug it in here because this is what we're going to be using. Now there's a few things we need to find. First is our GM. We don't know what our GM is, but if we again look at the notes, we can see just doing a command or control F and plugging in our GM, the following equation right here. And we're going to use this equation because of what we're given. Our equation says that our GM is equal to the square root of our 2 times our K prime times our W over L times our ID. All of that were given in this initial problem. And if we plug in all of these initial values, we're going to get that our GM is equal to approximately 1.424, and this is milliamps per volt. And that is how we would go about solving for our GM. Now we need to solve for our GMB. And this one is going to be a little bit different on the way we solve it. So for GMB, we are going to say that it is 0. So GMB is equal to 0, and this is without the body effect. Now, what about our GDS? Well, GDS is also equal to 0, and this is without the channel length modulation. Notice how it tells us to neglect the effect of the channel length modulation here, and it's a GMB without the body effect here. So with these in mind, that means that our GMB and our GDS are going to zero out. We are given our R naught, and that is right, well, our R naught, because we're solving for ID, is going to be our RD. So R naught is really RD. Plug in 17.7 times 10 cubed. We plug in the RS, which is 1.5 times 10 cubed, and then our RD, which is 17.7 kilo ohms, which is cubed. And then we are going to also plug in our R naught, which should be our RD. But there seems to be a little bit of a complication here. So for this, we have our R naught over our RD over R naught. And for the first one, we said that our R naught is our RD. So how would we go about writing this? Well, this is our RD. This is our RD as well. And this is going to be our RS. And that means this is going to be a RD as well. So this is just going to cancel out with each other. And for this particular part right here, it's pretty important. We have our RD and an R naught right here. Well, if we look at the notes, not this section, but the other section right here, we have our equation right here for the common gain amplifier. Now, if we look at this, we're going to see that it's not really included here, but it's the same kind of principle as this previous one. So Ri and R naught can be found using the shortcuts, just like we have right here. Ri and R naught can be found using the shortcuts. And with the shortcuts, we can say that our Ri, our subscript I, is going to be equal to infinity. And likely, like as well, just like our Ri, our R naught is going to be equal to infinity. Now, the problem is here we have our RD and RD, our R naught and RD. Now this bottom part has another R naught here. And this R naught, we said it was RD up here, but that's a little bit different. We can see that this one's a capital R, so that's what the capital RD is going to be okay to change to. However, we can't just change this lowercase r to a uppercase RD. We know that our R naught is going to equal to infinity. And also, likewise, we can say that our RDS, which is what our RD is for this equation, is going to be equal to and so what we can say if we look at the notes, and we can see this from previous right here, we have this equal to infinity. I don't think it's exactly mentioned in the notes for this one, so I had to add it in, that our R naught is equal to infinity. So if our R naught is equal to infinity, well, we basically have a small number over infinity, so this is going to be zeroed out. And now, if we plug this into a calculator, we are going to get that we have a 8.16 for our frequency voltage gain. And 8.16 is going to be the answer to this problem, and that's how we'd go about solving for it.